class. So the last intro to empirical formula screencast, that went on for quite a bit. So let's just make this real quick and go through this. So I got hydrogen and oxygen, all right? So I still have the percent, so I still need to go through my 3 steps for empirical formula, and then I'm going to get to the steps for molecular formula. So let's see what we got. So I got, for hydrogen, I got 5.9265, whatever. That's going to be over 1.0. Okay, so this is my percent for hydrogen. I divide by atomic mass. I got oxygen as 94.0735. And that is my percent for oxygen, and that's 16.0. So I go through this quickly. 5.9265 divided by 1. I really did just put that in the calculator. Jeez, yikes. And what a Monday morning this is going to be. So 94.0735 divided by 16. Okay, that didn't work out right. Let's try it again. 94.0735 divided by 16 equals, and I get, look at that, I get 5.8796. So I'm going to divide these two here. Now take a look. I got to say, let's make that into an 8. 75696, whatever. 96, there we go. Okay, trying to rush. Obviously, it's not working. Now, take a look at this. This is going to be a 1 and a 1. I know this is this right here. If I divide the two, what I get then is 1.0079 blah, blah, blah. Okay, so this is close enough to 1 to equal 1. So I have 1 to 1. So I have H. HO. Okay, so that's my empirical formula. Now, here's the step that I'm going to do in blue that goes to molecular formula. Now, the difference between empirical formula and the molecular formula is simply the atomic, or the molar mass. So here I have 1 for, you remember doing this? I do H, no, 1 and 1 times 1.0 times 16.0. Like this, I get 1.0, and like this, I get 16.0. Well, sometimes I do this. This is grams per mole, okay? You've seen me do this before in the blue. Sometimes I do this in kind of like a shorthand, and here's what the shorthand looks like. So I'm getting rid of all of that before you can write it down, and I do this. I do 1 plus 16 equals 17 like this. So here is the key to finding a molecular formula. It's actually pretty simple. So I'm going to do a fraction here. The fraction is going to be the molecular formula's mass on top and the empirical formula mass on the bottom. So 17.0 goes on the bottom here because that's what this is for my HO. Somewhere in the problem, you must be given the molecular formula's molar mass, and there it is, 34.016, blah, 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 blah. Okay, so 34.01. That's close enough. When I divide these two, so the molecular formula here goes on top, the empirical formula goes on the bottom. When I divide these two, what I get is the magic number. This number right here is the number that I multiply the number here and the number here, the subscripts for H and the subscripts for O, which means that my molecular formula is H2O2, okay? So now, so it's just one step further. The empirical formula stuff is all in green. The molecular formula is in blue. You must be given this number right there. You find this number by doing what I did in right above for the HO. So the 1 plus the 16, and then you add that all in. You divide the 2, excuse me, to get the magic number. That's it. And then that magic number is what is multiplied by each subscript in the compound. Okay. Let's do one more and then have you do the last one. Okay? So here, this one's even easier. This says, hey, the empirical formula for trichlorocyuranic acid, the active ingredient in many household bleaches, is O, C, and Cl. Okay, so they're all ones. So the empirical formula is OC as in oxygen, carbon, nitrogen, and chlorine. Okay, the molar mass of this compound is 232.41. Okay, that's the molecular formula's molar mass, so that goes on top. Now, here's the empirical formula. I have 1 oxygen, 1 carbon, 1 nitrogen, and 1 chlorine. So 1, 1, 1, 1 like this, times 16.0 times 12.0 times 14.0, okay, and times 35. I round this off to 35.5. So 35.5. I add these all up. I'm going to do it right here on my calculator so I don't make a mistake. So 16 plus 12 plus 14 plus 35.5 equals 77.5, like that. This is the number that goes up here, 77.5. Okay, so I divide those two. And then what I get is something 2.998. Obviously, this is going to be very close to 3. This is my magic number, which means my empirical formula is O3, C3, N3, Cl3, just like that. That's the molecular formula. All right, nice work. See if you can do the last one there, number 9.